26, welcome. For those of you who've not done one of our meetings before, we're going to start things off with officer reports and then talk about some subgroup reports and then have our main presentation for the night. So as far as presidential business goes, I want to make sure everybody knows about the big multi-club event coming up next weekend, the Ford Astronomical, Ford Amateur Astronomy Club's expo / swap meet / annual shindig. It's going to be in Dearborn from 9 to 3. The 28th. Saturday, the 28th. We sit last Saturday of the month. Same day as Stargate, actually. So we sent out an email blast for you all that included the itinerary. Our own Dr. Dale Parton is going to be doing a talk. So it's just, if you've never been before, highly recommend it. It's fun. We're going to have several club members there. We've got a table there. We've got, it's a great opportunity to pick up secondhand gear or get rid of gear that you don't need anymore. And the talks are always enlightening. So just highly recommend it. Next Saturday, 9 to 3. Another multi-club event that we normally do is the Selfridge Air Show. Unfortunately, as of this week, it was announced that the air show is canceled. So we and the Ford Club will not be doing the Selfridge Air Show this year. As far as other club business goes, I'm happy to announce that our new treasurer, Mark Miles, will be meeting with me and Dale Teamy next week to get him formally on the bank account so that that will be all taken care of. He is present at Macomb tonight if anybody wants to meet him. And yep. And will be fully operational as of next week. Dave, yes.
Yeah, regarding the swap meet. So if I had stuff to sell, someone's gonna have a table there that I could possibly put it at, or?
You would have to get your own table unless Mark has your shares with you.
Oh, okay.
If
I only have a couple things anyway, so I'm not gonna get a table for that.
it sounds like Mark is pretty willing to share, so.
Oh, thanks, Mark.
Yeah. Any other questions about the swap meet? Any other questions about a new treasurer? All right, that brings us to the less happy news that we still don't have a candidate stepping forward to be our secretary. We do want to emphasize again, secretary is a whole different ballgame than it was 10 or 20 years ago. You don't have to take notes by hand anymore. We've got all kinds of electronic support to make it easy on you. You can even use AI. I'm not really a fan of AI, but that is a thing you can do. Yeah, a lot of people are getting no choice as far as their workplace work goes. So if you are interested in joining the board, we promise we don't bite. Sometimes we even have cookies. And we would love to have some new faces on the board to join Mark. With that, I will turn things over to the first vice president for his report.
Oh, it's me. As of right now, we are fully booked through July. We have some spots open in July and August, I think. So if you would like to give a presentation, please see me. If you don't have an idea for a presentation, but think that you would be willing to give one, I have a list of presentations that people have asked for. So we could.
Oh, excuse me. Can someone call Dale?
He's there. He's here.
Okay.
Yeah. Sorry. Anyway, if you are willing to present but don't have an idea for presentation, talk to me. I can give you some ideas. But that's it.
All right. Come on in. Oh, hello. No worries. We had some technical issues. We're
Good to see you.
let's see. Normally Riyadh would give the second vice president's report. I do not see Riyadh on the call tonight. So I'll just remind y'all that we have Stargate is, the open house will be on the fourth Saturday of the month. So again, the 28th. Riyadh will be there, before sunset. So normal protocol, check out what time sunset is at night, arrive around sunset. Bring a red light, flashlight if possible. And if you, want to bring the gang some donuts and hot chocolate, everybody appreciates it, so. And keep your fingers crossed that we will have clear skies because we've been skunked most of our observing events so far this year. Let's see. With that, things go to the treasurer. Hi, Mark.
I have no report yet because I have not been able to get into the bank, see the statements and really start putting anything together. So we will have something next month, but starting next week, I should have full access and we'll get it going.
Perfect. Yep, nothing to report yet, but look for Mark's upcoming report in the WASP for April. Let's see. Secretary report. Secretary is vacant. Again, looking for candidates. Outreach report. Jeff McLeod is not on the call tonight. As I said, the big shindig in Selfridge, which would usually feature Jeff and the WAS and the FAC, has been canceled. We do not have a do-over at this time for Cranbrook's canceled Jupiter February event. That will be in August, will be the next time that Cranbrook is calling upon us for partial lunar and solar eclipses and the meteor shower. So expect us to be bugging you all in August to turn out. And that's it as far as outreach goes for right now. Cross your fingers for clear skies and more opportunities. As far as publications goes, our publications director said she would drop by the meeting, but she's not in right now. So just wanted to say again, WASP is out. Get in your submissions for articles and editorials and pictures before the end of the month so that we can debut the April edition on April 1st, if not earlier. That concludes our officers' reports, but I believe we have a subgroup report. I think somebody was cooking up something solar-wise.
Oh, really? You know, oh, I thought you were gonna do that, okay.
No, go ahead. You put in the work.
It wasn't much. Okay, we have 5 numbered sunspots on the sun's face right now. AR 4392 is larger than the Earth. NOAA reports a couple B-class solar flares over the last day, and that one sunspot has, let's see, a beta gamma magnetic field posing a threat for M-class solar flares. So the sun's just doing little flares. NOAA's latest forecast predicts 2 CME impacts this week. First on March 19th, second on March 21st. This is a timing double blow is perfect for amplification by the Russell-McFerron effect. Somebody needs to do a report on that because I have no idea what that is. Which boosts storms that happen around the vernal equinox. That's interesting. Yeah, moderately strong G-class geomagnetic storms are possible every day for the rest of the week, so look for auroras. There are a couple coronal holes on the sun, a really big one in the southern hemisphere, pouring out solar wind toward us, and another one crawling onto the face of the sun that is also pouring out solar wind. And that's pretty much it.
All right. So sun is not dead yet, but it's not as hot as it was a few months ago.
Might see aurora still.
Yeah, auroras are not out of the question. Double Star group. Double Star will be meeting as usual at the Stargate Open House Saturday after this upcoming Saturday, again, the 28th. So Riyadh will be there with his fancy eyepieces to split double stars as seasonally appropriate. Do we have any updates from astrophotography?
Yeah, it's been raining, cloudy. Cold as hell.
I was able to get the Monkey Head Nebula a little bit a couple weeks ago when we had clear skies.
Fantastic. Do you have it digitally to show us?
Give me a minute. You know what the funny thing is? So, I was streaming it, so I learned. I got people, talking to me and telling me what I'm doing right and what I'm doing wrong. And let
Okay.
me look for it. Give me a second.
Sure
And
thing.
or I may have it come back to me, but I didn't. I'm looking at it, and it looks like a monkey. They said, "Oh, you got it upside down." I said, "Well, there's no upside down in space," but I was looking at it apparently upside down, but it still looks like a monkey. It just looks like the monkey from Wizard of Oz. When you flip it over, it looks more like a monkey, like Planet of the Apes monkey. So,
Okay.
but I'm gonna need a minute to find it.
Very
So
good.
I got it on my phone.
So while Dave is looking for the Monkey Head Nebula, does anybody have any observing reports of anything other than clouds?
Oh, I'm coming to my last 3 posts for the Caldwell objects on Facebook.
Okay.
I've done all the Messier and I've done all the Caldwell, but 107, 108, and 109, which are the last 3. And if you want to go on Facebook, you can see it on Tuesdays. I post a couple of them each week. But if you wait more than 1 week, you won't see any because I'm done. You know that.
I've been observing in my social feeds that there was a meteor.
yes.
Yeah,
Oh,
let's
yeah,
talk about
yeah.
that.
Oh yeah.
I see photos of like meteor fragments and I think it's all AI spam. Oh, I found this big old chunk. I found it, and I see a different photo of a different chunk. I'm like, I don't know that anybody's found it.
So one of the blogs, one of the astronomy-based blogs that was in my feed, I think it's a meteorologist guy. He was recounting that at least 3 fragments of the Ohio bolide have allegedly been recovered.
Okay.
They about yay big.
So
So
I saw one that looked like.
yeah, no, I no brick size, just you know,
Chondrite?
I can't tell. They look black. It was not shiny, so probably it was just looked like a lump of coal. Yeah.
Storm that way.
No. So yeah, fun time to be a meteor hunter in Ohio. Any other observing type reports? Anybody do any traveling? Any sort
I
of?
got one.
You got one. Fabulous, Dale.
Not exactly me, it was my sister. She went to Norway on a aurora hunt,
Nice.
and she shared some pictures with me. I'm going to share them with you right now.
There you go. Yeah. Nice.
Very cool.
Yeah, that's in fact, I think that's the Pleiades that are showing up over to the
Yes.
left there.
Right at
Yeah.
the top.
Yep.
Yeah.
Another shot over the lake.
Beautiful.
That's a Pleiades.
That's terrific.
Oh, wow.
They took a couple boat excursions to catch some of these as well.
That's great.
Wow.
In fact, I think this one was during the excursion.
That's cool.
Did you actually see that purple or is that your phone?
It's her phone. I wasn't there.
His sister.
Sister.
Wow.
That is terrific.
My boss actually took a trip this past week to Fairbanks, and one of his main goals was.
There she is, enjoying the view.
Very cool.
He saw aurora on 5 of the nights there. Like
Nice.
they had great weather, so he was pumped. That was the first time he saw aurora.
Fantastic. Oh, wow.
Yeah.
No, that's
Were of like quality, but yeah,
So to
lots of
the,
greens and a few birds.
She's still there or winging her way back. I don't know.
so clearly if you want to see anything, we all gotta go to Norway.
Yeah, okay.
to Bob's question, as those who imaged the auroras in the last couple of years know, your camera does see a lot more and a lot further into the red than your eyes do.
Yes.
But the green, anything that you see that is bright green, you're going to easily see naked eye.
All right, so I think that concludes our observing reports. Dave, throw up the yes. Beautiful. You said monkey head nebula?
Flying monkey nebula.
Can you zoom that, Dave?
Oh, I understood.
Yeah. Nice.
That looks like.
Oh, wow. It does look like a Wizard of Oz monkey.
Upside down.
Let me see, which one is that?
Well, you know what? You might be able to get the eyes there.
What is that NGC?
2175.
I am really surprised there are no satellite trails through that. Or did it filter them out?
Dave, that's a question for you.
You can manually.
Dave, did you have to filter out any satellite trails?
Shot.
Yes.
There's another shot.
Are you muted?
Don't see him
I
anymore.
don't see him either, but he's sharing.
But he's sharing. How's that work?
Guess he's showing that.
There it is.
There you are. Dave, come in.
He's talking.
Can't hear you, Dave.
You're on mute.
You're on mute.
Doesn't look like he's on mute.
It doesn't
He's
look
not
like he's on mute.
Tell him to wave if he can hear you.
Dave, wave if you can hear us.
We can't hear
We
you.
can't hear you.
Yeah, we can't hear you.
Weird.
Type it in the chat.
How about now?
Yeah.
Yes.
All right, I think my mic might have turned off. So yeah, so this is what they told me, or the other picture. Sorry, it's so crappy. I thought I had a better one. But
That's
this is how I was when I was streaming it. This is what it looked like, right? And I'm like, well, that looks like a monkey. It didn't even question it. And they go, oh, it's upside down. But there's no upside down in space. But they said it was upside down. So then I flipped it, and I'm like, oh yeah, that kind of looks like that looks more like a gorilla, I guess maybe. But it looks like a monkey too. So
It looks like the thing from the Fantastic Four.
so I thought that was a cleaner picture, but oh well. So
No worries.
Yeah.
Better than what I can do.
and it was only 19 minutes worth, so in Border late. So
Wow. Very cool.
but I what I liked about this time of year is I've been getting seeing objects that I've never been able to capture before. So it's been kind of exciting.
I have a question. Is that a dying star or the opposite?
Mike O'Dowd has the question. Is that
I didn't hear.
is it a dying star or is it a newborn star?
Oh, you're asking the wrong person.
That's newborn. That's likely newborn.
You think it's a stellar nursery?
Ken will know.
I don't think that's a dying. star.
We'll look it up.
Yeah. Although, you know what I did? Because when I do these lives and I never know, I can't like Google things fast enough. So I asked Chat GPT to, I said, give me like all the top like Messier objects or something and give me their distance, their size, and their age, but no history behind it. So I can do a quick
wow.
reference that way.
Yeah, it's a star forming nebula.
Yeah.
So we've got confirmation from the room. It's a star forming nebula.
Oh, okay. Good to know.
Cool. All right. Any other photos, observing reports, weather phenomena?
Yes, I have one.
We almost got the blue.
I wonder why this mic stopped working.
I have a report from Arizona.
That's what we're waiting for. Take it away.
Temperature here is a little bit different from what it is at the Warren Astronomical Society. The temperature right now is 101 degrees.
Oh,
Completely clear sky for the last week. And our sun is pretty active today with not one group with 9 sunspots and 15 prominences. I do have a poem to offer today. It's written by John Dryden
nice.
in 1667 to celebrate the comets that we are seeing right now. To see this fleet upon the ocean move, angels drew wide the curtains of the skies, and heaven, as if there were wanted lights above, where tapers made 2 glaring comets rise. Whether they unctuous exhalations are, fired by the sun, or seeming so alone, or each Some more remote and slippery star, which loses footing when to mortals shown. Or one, that bright companion of the sun, whose glorious aspect sealed our newborn king. And now a round of greater years begun, no influence from his walks of light did bring. Have you not seen when whistled from the fist, since some falcon stoops at what her eye designed, and with her eagerness the quarry missed. Straight flies at check and clips it down the wind. Thank you very much.
Thank you. All right, 101 degrees. I'm glad I'm not there, frankly. That's too hot for me. Okay, we have a bit of time for Ask an Astronomer a question. If anybody wants to ask a question, no question is too off the wall. Anybody got a burning question they want to ask their fellow astronomers?
Well,
Jonathan.
I have this section was originally called Ask a Stupid Astronomy Question, and I'm going to ask one. How do we know that what blew up over Ohio was a meteoroid or an asteroid? What's the difference?
That's an excellent question. So Jonathan is asking, how do we know that what blew up over Ohio in the night is a meteoroid versus an asteroid?
This,
Bobby, if you got it, take it away.
all right.
Sorry, Jerry.
Sorry.
All right, Connie actually saw a post on Facebook saying it was space debris, and I'm like, no, it wasn't. All right, so there's a lot of dust in space. So when you see a meteor going through the sky, that can be a size of a grain of dust. An asteroid, before that chunk of dust hits the Earth's atmosphere, it is a meteoroid. Anything larger than a meter, say about like that, is an asteroid. So the thing that hit the Earth was an asteroid, and you can tell when something like that blows up in the atmosphere. You'll see the line. It goes really fast through the sky, and it'll go flash, flash, and you can see a line in the sky. Space debris, space junk re-entering goes really slow and often fragments into several different pieces. So a meteor is like that, and a bolide is one of these things that blows up. So when you see a meteor, that's just a shooting star. Something like hit Ohio, it does a flash, and I actually saw videos of it scaring dogs. So
That's the sonic boom, probably.
yeah, so again, anything larger than a meteor, any space debris larger than a meteor is an asteroid. So
A
that goes,
meteorite is?
a meteoroid is a chunk of rock or iron left over from the formation of the solar system that's floating around and
My understanding is that it hits the ground, it has a different name.
Meteorite.
that is a meteorite,
Yeah.
right? Something that you can pick up. So
Right.
meteoroid is floating around. Meteor is in the atmosphere, bright and flashing. Bolide is one that explodes. Meteorite is one that hits the ground that you can pick up and take home and
So do we know
sell
how
for
big
lots
this
of
thing
money.
was?
They said it was about 6 meters.
I heard 6
I heard
meters,
6
yeah.
meters.
So 18 feet, well, about 20 feet across.
Story here.
Yeah,
It is pretty, it's the size of a
size of a car.
tractor trailer.
Yeah,
So it's an asteroid.
yes,
Yes.
I'm not doing it again, Jerry.
yeah.
And nobody saw it coming, right?
No, to my knowledge, nobody saw it coming.
Nope.
No.
Well, so in terms of sorry to ask after you've already said that, but in terms of the ones that we're tracking, aren't those more 3 meters and up?
Not necessarily.
Not necessarily.
Right.
I've seen it at the Minor Planet Center. I've seen things like 1 meter, but yeah, it's the larger they are, we're finding more of it. These ones that are smaller than this room, it's hard to see those.
But I thought I thought the thought was that at least in the inner solar system, we were tracking like 80% of things larger than 3 meters or something like that.
That percentage is.
But
There's actually a graph that shows the discovery rate of, actually, I put that up, I'll put that up at the break, but the discovery rate. We've discovered most of the things that are, larger than 1 kilometer. We've discovered a lot of the things that are below 140 meters. But, but anything smaller than that, there's millions of them.
Yeah. You also might have a situation where you have the breakup of a comet. Got lots of comets going around, so we've got lots of pathways. And that will be
The junk is always being renewed.
being renewed, it's there all the time, and every one of the major comets have produced the asteroid.
I guess if it's coming in at a weird angle or like from the direction of near the sun, or if it's coming straight on, it would be more difficult to detect those sort of things. So for a lot of variables, I guess involved. Sure.
Yeah.
Okay,
Yeah.
Google says over 90% of near-Earth objects larger than a kilometer have been discovered.
larger than a
Well,
kilometer.
kilometer,
30% of mid-size, 100 to 300 meters have been found.
Okay. So
Yeah.
probably nothing near that for stuff.
Yeah.
That's as small as.
yeah.
Plus the fact we're a planet made of almost all water, so the chances of you really getting kilometers pretty slim. Even if it's here.
All right, that was a surprisingly fruitful dialogue. Any other questions? No questions? All right, with that, why don't we have the newer faces in the room introduce themselves? Who's attending what? Sure. All right, for those of you who missed it at the beginning of the meeting, Diane Hall, the current president.
Long card carrying member.
Michael Dowd. Dale Parton.
Jerry Voorhees.
Bob Tremblay.
Dale Hollenbaugh.
Stay home.
Angelo DiDonato. Bob Berta.
Maria Bogner.
Sonny Spilos.
Jonathan Cade, first vice president.
New member, Deja Strong.
Mark Miles, treasurer.
Ken Hiley.
Mark Jacobison.
Mark Kitzier. Larry Frederick.
I'm Apollo, I'm a new member.
Fantastic. And Apollo is one of the mods on our brand new Discord server,
Yes.
Which isn't quite open yet.
which isn't quite open yet, but we're working on it. So,
I have an astronomy question. So
yes,
I've seen a little bit, but I didn't spend any time looking at it. That's comets, upcoming comets. I hear there is one that they are
hyping.
hyping that is potentially bright enough to see during the daylight if it doesn't break up. But it's, well, what do we know about this and when and?
We're getting it.
I-
For sure.
Yeah, I saw the story and I was just like, yeah, get back to me in 3 months or whatever. So I don't, is anybody following it more closely?
Northern hemisphere, southern?
Yeah, it looks like Comet Maps is a sun grazer that was just discovered on January 13th.
Okay,
And it could brighten to as much as minus first magnitude,
that would be pretty darn good.
which would be really.
Yeah,
unique.
that would be nice.
Visible from what part of the earth?
That is what I'm trying to figure out from the,
It's called maps.
Maps.
it is all, so far it's all northern hemisphere.
Right.
Interesting.
Well, yeah, it's gonna stay in, well, no, it's moving into Orion as of May. So
Oh,
we will have lost it by then, but it's in Serpens through April. So I
Cool.
think we should be able to see that.
very cool. All right.
I have an answer for you, Jonathan. You take a look at the Minor Planet Center here, and there are some asteroids that are 2 to 7 meters in diameter that they're tracking. But the 2 and 3 and 5 meter ones are all like from 2020 on. So before 2020, they're larger, but after
Okay.
2020, they're getting smaller and smaller.
Fascinating.
Yeah.
Yeah, and it's going to reach the sun perihelion on April 4th.
April 4th.
You'll
Wow.
be able to see it by April 1st.
So
Okay.
at the end of April, if we're gonna see it, if it survives it's gonna approach the sun to 0.005
Yikes.
astronomical units, so well inside the
Oh,
orbit of Mercury.
Super close, so probably brilliant.
Yeah, sun grazer.
Or it'll get super bright.
But we won't be able to see it because it's next to the sun.
So
Or
if
difficult.
if it doesn't break up, yeah, it could easily creep up.
Okay, so we might have a really cool comet coming imminently.
So might see it.
Somebody might see it, yeah. All right, very good. Well, there's no additional news to report. We'll take a 10-minute break, reconvene in 10 minutes, and have our feature presentation.
For those who are on the call, can you see this well? Can you see the presentation well?
Yes, we can.
Yepers.
Great, sounds great. So we'll be starting in about 7 minutes or so.
Let's see, is this mic working now? Can you hear me?
I hear echo.
You hear an echo? You hear an echo? You hear me twice? Actually, I made my phone. Can you hear it? Do you still hear an echo now?
A little bit.
Really? Hmm. Let me make
So
sure I get the
very nice
noise.
reverb effect.
That's extra. See if I got the noise cancellation on this. Oh, now I think I got the noise cancellation on, maybe?
Perfect.
Alrighty. Yay. Every mic's just a little bit different.
Oh, yeah.
All right. We are back from our informal no snack break.
Attention!
So if everybody's back in their seats and comfortable, at this point, I turn things over to our first vice president, Jonathan Kay.
All right. So we have as our speaker tonight a former president of the Warren Astronomical Society, also a former secretary, second VP and outreach chair. Bob Berta has been a member of WAS since 2004. And he is also, as you can see here, Jet Propulsion Lab Solar System Ambassador, a member of the Oakland Astronomy Club, Seven Ponds, and the San Francisco Amateur Astronomers, which is where he got into amateur astronomy. Helped throw a big birthday bash for John Dobson, the inventor of the, or the popularizer at least, of the Dobsonian telescope. And one thing, here's a factoid about Bob Berta. He actually discovered previously unseen since the 1940s or 1930s photographs taken by Ansel Adams in the archives of Pacific Gas and Electric. So to introduce the factoid man, there's a factoid. Take it away, Bob.
There you go. Greetings. Hopefully everybody can hear me. This is going to be an unusual talk because normally I do talks more at a higher level, you might say, based on my interest in whether it's astrophotography or, science about astronomy and everything. But when I go out and give talks to the public in schools, I've found that the one thing that really gets people hooked on astronomy is don't just say, there's a planet, there's another planet, there's the moon, or, what's that up in the sky? You want to look through a telescope. But what really gets people hooked is when you start saying, let me tell you a little interesting story about such and such. And people say, well, that's really cool. That's interesting. Also, I found, especially when you go into schools, if you tell somebody that it's so many thousand or 100,000 or 1,000,000 miles to something in space, that's going to go over their head and they could care less. But if you start putting it in terms that they can understand, like you're going to see here, people will remember that. It's like a crutch. I like to give crutches to people to remember stuff. I started in astronomy when I was probably about 6 years old. Had an interest in it, passing interest, looking at books and everything. But where I really got into it was when I went over with my mom to visit her friend. And the two ladies were talking, and being a young kid, I was bored silly. So her husband, who had just recently retired from the fire department, said, come here, I'll show you something really cool. So he took me out into the backyard, and he had a Tasco, I think, telescope there in his backyard. And that was evidently his gift at retirement from the fire department. So he looked through it, and he said, what do you see? And I said, well, I knew enough about it. I said, that's Saturn, because I could see the ring around it, etc. And he said, right. Well, he started giving me all these factoids, which I'm going to talk about some more in a second. And those said, you can learn more about those if you go to the library and get books from the library, whether it's the school library or the city library. So naturally, next few weeks, I made a point of going to the libraries and getting all the stuff on astronomy. And as I've done in a prior talk, that's what got me launched. I started saying, if I had a telescope, I could actually see some of this stuff. If I had a camera, I could take pictures of it. Well, I had bigger dreams than money or realism. But over the years, I got into it. I'm now 78 years old. And it's been a lifelong love of astronomy because it brings me so much joy, not just for my own personal self, but to share it with other people. So hopefully you get as much joy out of the little stories I'm going to tell as I do. The first thing I like to say is the knowledge of the universe gathered in the past quarter century surpasses all the discoveries the entire century preceding it. And that in turn dwarfs all human learning since the universe began. So in other words, as much as you might think, I've learned all I can about astronomy. Well, guess again. And one thing I like to tell people is that everything you think is true about astronomy today, no matter what the scientist or the mathematicians or anybody else tells you, I can just about guarantee is not quite as accurate as they say, because they're gonna find new discoveries, new exploration, new telescopes. They're gonna say, guess what? What we've believed for so many years, well, in the dumpster. Now it's this in truth. Okay, let's if I continue on here. And that's not it. How do I advance on here?
Can you hit this, please?
That doesn't do it.
Maybe click back, no, because I think, why do I see, okay, can you just click on the presentation with the mouse?
Presentation.
Because I think right now, just, Zoom is selected, so if you click on the presentation with the mouse.
It's not doing it.
Just a left click, right?
Yeah, left click,
Oh, there we go. Okay,
and now you should be able to hit space.
okay, okay. There's a lot of areas you can enjoy in astronomy besides looking to a telescope. And, you know, one of my favorites are talking to people about factoids. Yeah. Oops, wrong one. Here we go. Well, it's really neat. I do a lot of astrophotography. This is one of the pictures I took. But to me, it's nearly impossible to believe the size of the universe, how far things are away from us, how massive objects are, and how amazing the universe is. And there's new telescopes, the Webb telescope, et cetera, that are helping man open the secrets of the universe. How about time travel and the possibility of life beyond Earth and new discoveries? We're going to talk about that. Hey, this is something I use in my presentation, especially into schools. And some of you might say, well, this is really obvious. We all know about this, but still, it's a good tool to use to talk to people. And this is about the relative size of our own planets. These are all, I guess, computer-generated pictures that show the relative size of Earth, Venus, Pluto, Mercury, Mars, and a few other things down the road. And of course, being an old guy that I am, I show Pluto on there. I haven't still given up on Pluto. And what are these planets? How are they different than the other planets? Yeah, they're rocky. These are all rocky planets. You could stand on them. Now, you might need a spacesuit and a way to get there, but you could stand on all these planets.
Not might,
Pardon?
not might.
Yeah,
Well, you don't need a spacesuit for the one.
yeah, that's
Not
true.
Venus, not Venus.
Yeah, that's true. The one that left you will, that's right.
Venus.
Well, it depends where you land. If you land in the ocean, you might want a wetsuit.
Doesn't matter if you have a spacesuit on
Yeah, maybe
Venus.
yours. Yeah.
Yeah.
Then we come to the gas planets, Jupiter, Saturn, Uranus, Neptune, and here's the Earth down to Pluto. And you can see the relative size of those. You know, Pluto is pretty small. Earth is pretty small compared to those. But in reality, there's a big difference there. Besides being gas, they also are much lighter. In fact, I don't know if you realize it, but if you went on to Saturn, took Saturn and had a giant bathtub and put Saturn in it, it would float, but it would leave a heck of a ring around the tub.
Yeah.
Okay, now let's go to our sun. That's when things start getting larger. I won't say really big, but larger. Our sun is a, middling star, not giant, not a huge star, but it's special to us because it helps support us. We can live here and not either burn up or, get cold or too hot. The Earth is a little dot, as you can see down there, and Pluto is a little teeny dot down there. Well, look how big the other planets are. Well, as you all know, there's a lot of other stars out there. These planets, stars rather, these are all stars that all of you will know about, especially if you've been in astronomy anytime. These are all stars you can easily see during the year. And Sirius, Pollux, and Arcturus are pretty large stars. And you see our sun down there. We don't look so big, do we? Well, remember I saw how big Jupiter was on that previous picture. In this picture, there's a bunch of pixels making up the image. You know that digital images, right? Jupiter is 1 pixel in size compared to our sun at that scale. By the way, you might say, where's Earth? The Earth is invisible at this scale.
Microbe.
Yeah, it's a microbe.
The pixel.
Now let's go on to some of the other stars. Betelgeuse, Betelgeuse, there's all different ways you can pronounce it. Antares, Aldebaran, Rigel, Arcturus, Pollux, down to Sirius, down to our sun. Our sun is 1 pixel in that scale. 1 pixel compared to those pictures of Antares. And yet these aren't the largest stars. There's other stars that are much larger, probably 5 to 6 times larger than the largest star here. And there's probably some even larger than that, but they're pretty massive. Another thing about this picture, what's the one thing that kind of different about those pictures of the stars?
Oh, the big ones are red.
Yeah, the big ones are red. The small ones, well, the smaller ones are sort of a middle yellow, like our sun is a yellow star. You can't see it in this picture because it's only 1 pixel, but Rigel is blue. The difference is the big stars tend to be red giants, very big. They last for a really, really long time, billions and billions of years. Rigel is so hot, it burns itself up, so it'll have a much shorter lifetime. Our sun is going to be good for about a total of, what, 8 billion years? We've probably gone through 4 billion years of its life right now. So you can start looking for a new star to go to in a few billion years. So you might want to start getting a real estate agent for your house. Yeah.
Pick me up, pick me up.
Okay, now let's talk about the one thing that people always ask me is, well, how do you know where all those stars are and what they are and where the planets are? And how do you find them in the space? Well, I tell them a good astronomer knows the name of every single star. He can see it and knows exactly where they are. Not, right? There are names for the brightest stars. And just like when you drive down the road, you come to a corner and you know that corner's at the corner of 25 Mile Road in Hayes or whatever, right? Well, all these stars are laid out in a coordinate system. And this coordinate system has a way of delineating where they stand on that pattern. So a star won't go like this, go like this. They stay pretty much in the same place. They do change over millions of years and everything, but to go large distances, they won't do that. So what scientists assign are space coordinates. The space coordinates are based on right ascension and declination. Okay, and if you look on a chart of stars, that's how you find them. And that's how if you have a computerized go-to scope or how you're trying to find something in space, that's how we find stuff. On a computerized scope, you could actually go in and plug in its coordinates on it, and your computerized scope will go to it. If you use it the old-fashioned way, with just a push-pull type of a telescope, like a Dobsonian, and by the way, in my introduction, you mentioned I knew John Dobson, yes, because he is one of the founders of my club in San Francisco. I knew him very well. Don't ask me what I thought of his personality, but that's another story. Anyway, but once you get into astronomy and start finding stuff, what you'll do is just look at the brightest stars you can see at the sky at night, and you do what is called star hopping from there. There are charts, maps, you might say, of all these stars, and you go to them and it might say, well, this is over so many degrees over from this star or this planet, whatever. So you have different ways. You can have the hand method, okay? One finger, little finger. Tip of your finger is about, what, a half a degree, 1 degree. You know, you can go like this. That's about 5 degrees. Like this is about 10 degrees. If you have a bigger hand, smaller hand, it works differently. But for the average person, that's a good way to kind of measure the distances between the stars. But if you get lazy like me, after you've been doing it for a long time, you start saying, you know, heck with this. I'm just going to go out and use my computer. And they have ways you can very easily find stuff in the sky with even your cell phone. There are apps for your cell phones, whether you have an Apple or a Galaxy type of a phone, Android. They're relatively inexpensive. Even the expensive ones allow you to take your cell phone, if it has a compass built into it, go like this, aim it in the sky, and all of a sudden it matches up with the sky, and it tells you exactly what's up there, okay? There are other things you can buy for your telescope will have to help you find things also. One is books. Remember those things you used to buy and put them on desk? Yeah, but there are great books. There are catalogs, giant catalogs that are made up. They're beautiful collections of all the maps and stars. You can use that to find your way around also. And you say, well, gee, how much do those things cost? The apps are very inexpensive. Probably the cheapest ones are around $5 or even free. The fanciest, most expensive ones are probably around maybe $35 or so, $40. And if you get the some of them, like a lot of us like Sky Safari, which is one really good one, you can buy different versions. What you do is wait around certain times of the year when some special solar event or, going to be a bright special appearance of something, one planet, and they'll say, we're going to give you a discount for the next 2 weeks on this app for your phone. And they're a great thing to get. You can buy books also, go to the library, you can, or library, you can also take them out. But generally, those tend to be kind of unyieldy, especially when you go out in the field and the dew and everything, and your nice books also get covered with moisture and dew, and kind of your nice collection kind of gets messed up. So there are solutions to that, because you can buy books which are designed for being used outdoors, and they have, plastic coated coatings on them and everything. Okay, now let's go on from there. Let's talk a little bit. Some of the things you're going to see at Sky. Okay, most of you who've been in astronomy at any time at all know about the Orion constellation. That's about 20 light years from us, and as far as 2,000 light years from us. You could never actually travel to Orion. The pattern would dissolve as you approached it. In other words, by happenstance, all those stars just happen to show up where they do. If you traveled to them, you'd actually probably travel past some of the stars, and all of a sudden you still see some of them out here. So you really don't go to a constellation like that. Okay, let's talk about a light year. That's really, to me, is very interesting, because a light travels at 186,000 miles per second, which is really quick. Remember I said in the beginning that I don't like to talk to people and say, this is exactly so many thousand light years away or whatever, because people just forget it instantly, right? But think about this. If you could run at the speed of light, and you ran around the equator of the Earth, you could go 7 to 8 times around the Earth in 1 second. 7 to 8 times around the Earth's equator. When I go into schools, I tell them, your teacher has a globe there. You can't take your finger and go like this 8 times in less than a second. And how do you think you could possibly go that fast, go around the Earth's equator in 8 seconds? I mean, 8 times in 1 second. So it's pretty quick. Let's talk about relatively what that means. If you could, here we go. You could run around the Earth's equator in less than 1 second, but in a year, light travels 5,880,000,000,000 miles. Okay, so you think, well, you can go really quick. You could probably easily get to another star, right? Well, not exactly. The Big Dipper in Canis Major is nearest to Earth of all constellations. This is still 80 light years away, and the space shuttle would take 2 million years to get there. So you can't say, let's jump in the spaceship and let's just go there. Not only that, what you're seeing is past history. How many of you believe in time travel? How many of you time traveled? Anybody here time travel?
No, but they have
Okay,
subatomic particles that went faster than
right. Well,
the future.
you can experience time travel. You can experience time travel by looking up in the sky. Because when you look up in the sky and see a star up there, you're not seeing that star today, depending how far it's away from you. For instance, the Andromeda galaxy is about 2.5 million light years away from us. So the light you're seeing from that took 2.5 million years to get from there to your eye. So you're not seeing today, you're actually seeing 2.5 million years ago. Okay, even when you're standing just a short distance away from somebody, you're not seeing it instantly. I believe if you're 10 foot away from somebody, you're seeing them actually a billionth of a nano, or was it billionth of a nanosecond?
10 billionths of a nanosecond.
10 billion, yeah.
It's 1 foot per nanosecond.
Yeah. So anyway, so when you go to your wife and tell your wife, gee, you're looking better now than ever. Well, yes.
Bob, I do just want to say, everybody here is time traveling at 1 second per second.
Yep. Yep, in fact, I'll tell you just how fast you're traveling in a second here. The Earth circles around the sun at 66,000 miles per hour. Our sun and planets are moving towards Vega at 44,000 miles per hour. We're also on a journey around our galaxy at 720,000 miles per hour. And the Andromeda galaxy is about 2.2 to 2.5 million light years away from our own galaxy, the Milky Way, and on a possible collision course with us is approaching us at the speed of 186 miles per second. So that means we will cross paths in about 2 or 3 billion years. But we probably won't even notice it. I don't know about you guys, but I'm sure I won't notice it.
Some of the friends will be doing
Okay.
I've got big plans.
And I talked about some of the stars already, but in our the Orion galaxy, there's a Orion Nebula, which is a cosmic nursery, which is peppered with a bunch of countless infant stars. It is so huge, 30 light years, it would take our fastest rockets 500,000 years just to cross the Orion Nebula. Okay, you say, well, how about some of the stars there? There's a star, the pattern of all the stars up there was known by the ancient Sumerians. The star pattern to the ancient Sumerians was a sheep, and the star known as Betelgeuse, Betelgeuse means armpit of the sheep's. Probably it's the least appealing name for a star in the universe. And yeah, the well-known star in Orion, Betelgeuse, is a single thing most of us will ever see, the single largest thing we will ever see. If you scale the star to a 20-story building, the dot at the end of a sentence would be the size of the Earth.
Right.
Well, it's pretty big. Okay, let's continue on here. People ask me, well, we talked about the constellations. What is a constellation? In effect, most of you, when you went to school, or young kids, who I had books, paint or not paint, go number the dot, we call go into dot to dot to dot, 1, 2, 3, and you create a picture with it, right? That's basically what the ancients were doing. If you go to this star and that star and that star, it looks like something, like a boat or sheep or whatever, right? Well, lost my place here. There we go. Okay, there's a lot of stars up there, but you think about it, on those ancient people, what they were familiar with, that's what they would name the constellation patterns after. And the little cartoon I have up, I don't think you can see it very well back there, but it says a winged horse. Nope, I don't see it. Perhaps a few swigs from this amphora will help. The constellations, how they were created. And that's probably not too far off. You might look at the constellations on this side of the equator versus the ones on the other side of the equator. And the ones on this side are more named after, the gods, the Sumerians, etc. The ones on the other side are named after things that seafaring people would recognize, the water pump, a couple other things. So that's because the people were going south of the equator were looking from things that they saw because they were sailors. And today, if you're making your own constellations today, you could probably find, telephonium, other things named after things we know today. Okay. Okay, people say, man, there's a lot of stars up there. But on a really clear night, there's probably only about 3,000 stars you can be seen on the clearest night with your eye without telescopic aid. That's in a rural sky. Around here, you're not going to see much of anything. In reality, you could count every naked eye star in under 20 minutes. But when you apply the light gathering ability of a binocular or a telescope, you see a lot more. People ask me, when you have a telescope, say, wow, that thing must be really powerful. I'll bet you can see a lot of really big things and even bigger things on that with your telescope because it's so high powered. It's not the magnification we're looking for. It's the light gathering ability. A bigger telescope is not valuable because it's got a higher resolution or a higher magnification. It's valuable because it has bigger light gathering. You think about your eye, your eye retina is about this large, very small. And that's a light gathering ability of your eye. Your eye also is gathering a snapshot in time. through a telescope, your eye has now become, instead of that big, maybe a 5-inch telescope, 8-inch telescope, 22-inch telescope, or a monster. And that is becoming what we all know and love about astronomy, and what we all aspire to is a light bucket, a big telescope that can gather a lot of light, so you can see a lot more stuff. Okay, now here's the next question. Okay, you all know about weightlessness, right? Okay, let's build the world's biggest pyramid, you might say. Let's build it on the Earth all the way up so that the space shuttle up here, that's the same height from the Earth. So you're an astronaut at the top of that pyramid. How much would you weigh up there?
A little less than ground level.
Yeah, a little bit less maybe than down here on the Earth. Very little, much different, very little difference. And can anybody tell me what the reason for that is? Are you really weightless in space, or is there another factor that's causing that?
You're constantly falling.
Yeah, we're falling, constantly falling. What we've done is we've reached the escape velocity. When you take a rocket, go into space, we're now right at the point where you're constantly falling, you might say, around the Earth, falling. You point a reach of equilibrium. So that's why the astronaut floats in space. Can you experience that on Earth without even flying? Yes, you can. Get on a swing. Remember when you're on a swing, little kid, like this, and you get up here and go back this way, right? So when you go this and go this way, you're actually, for a microsecond, you're pretty much weightless. Same thing. So that's a way of experiencing it. So that's the way I try to explain what weightlessness really is. And also, anyway along my talk, if you say, I don't quite agree with you, or I don't understand that, raise your hand. Okay, let's talk about the distance going to places.
Bob, is there another slide?
Yeah, pardon?
Is there another?
Oh, yeah, let me switch here, I think. I think that may be. Okay, here, the speed of light, I mentioned 186,000 miles per second. What would traveling at that speed be like? Okay, let's say you hop onto a ship.
Impossible unless you're a
Yeah.
photon.
Yeah, you could not go at the speed of light. That would take as much energy as the entire universe is used. But you could go back at maybe a less percent of that. But what's going to happen when you do that? Okay, let's say I get onto a spaceship and I go at maybe 70% of the speed of light going somewhere. Then I said, okay, I'm going to go back home. Turn around and go back home.
Everybody's gone.
Okay, if you left for 5 years, how old would you be when you got back to the Earth?
I don't know exactly. You know,
Yeah, I don't know right offhand, but you'd be
if you
probably
went-
hundreds of years, or
if
thousands
you
of
went
years
to the
old.
To the center of the galaxy, Milky
Yeah.
Way galaxy, you would get there in 42 years at 99% of the speed of light.
Right.
And it'd take you 42 years to get back. And everybody on Earth would be 57,000 years old.
Right. So,
Time dilation.
yeah, yep, time dilation, yep. So you would still be, what do we say, 22
Yeah.
22 years old, but everybody back here would be now 50.
I got a question.
Yeah,
If, as you approach the speed of light, time slows down.
For years.
Mhm.
Now, a photon travels at the speed of light. So does it experience time?
I don't think it really does.
Not really.
No.
It doesn't.
no,
A photon doesn't know what time is.
yep. You'll have to watch at home. No.
And accordingly, if you could go past the speed of light.
Yeah.
You would go backwards in time.
Right, yep. It's fascinating, and that's,
The problem.
Yeah.
Excuse me, and the problem with it is, the closer you get to the speed of light, the mass.
Yes,
Yeah,
mass
the
increases and you don't have enough energy
You can't.
to approach
you
it.
can't
Yeah.
have
Yep.
Yeah, that's Einstein's.
Yep.
Special relativity of thing.
Right.
but now we're getting in the area of, a little bit,
Yes.
beyond this, we're trying to get down to something that the average person can understand. By the way, I've got handouts with all this information on it. And so at the end, I'll give them out. The reason I don't like to give them out ahead of time, because everybody will be reading to it and they'll all be hearing this stuff. Okay, let's see now here.
universe is expanding faster than the speed of light.
Pardon?
Explain to them why the universe is expanding faster than the speed of light.
Go ahead.
What happens is that you're not talking about a mass. What you're talking about is space.
Yes.
And in space, you can go faster than the speed of
Yeah.
light, and space is expanding. And we're finding out that the universe may not be as old as we think it is because of this particular phenomenon. That it expands. You can expand faster than the speed of light, so things way out there are moving away from us.
And who discovered that?
I
A
think
guy by the name of Hubble.
Yeah.
There's Hubble,
Yep.
also Oppenheimer.
Yep. Hubble constant.
That's like for
Yep.
Henry XI.
But it gets a little.
Well, he convinced Einstein, because Einstein thought the universe was static, believe
Yeah.
it or not.
Right.
His theory actually only really works well when it says the universe is collapsing or expanding.
Yeah.
But Einstein didn't believe it, so he put a cosmological constant into his equations to fudge it, to make it static. And
Yep.
actually, in the 1920s, he went to California, and Edwin Hubble showed him, hey, look, redshifted galaxies, they're all moving away. He convinced Einstein.
Yeah, that's right.
But his own theory was telling him contrary to what he was thinking. That's why I say Edwin Hubble.
Yeah, there you are. Edwin Hubble is.
And they named the telescope.
Oh, I'm sorry.
That's all right.
Sorry.
No, that's all right, though. That's good. That's why I like to have the little crosstalk. I should get the audience involved. I forgot to show the slide earlier. This is the information I gave before. But the one thing I forgot to mention is the very last point. So moving all those speeds. So if you ever get pulled over for a cop for speeding, don't tell the cop how fast you really are traveling. Hey, this is the Webb Space Telescope, and most of us.
Pink.
Pardon?
It is pink.
No, it's not pink. Well, this is an artist rendering.
No, it is.
Oh, it is pink?
Yeah,
Oh.
the foil
That's-
is actually pink.
Oh, it is pink? Huh. Anyway, that is, people are more familiar with the Hubble now. I mean, the Webb Space Telescope is now. But the thing I love to show about that is this picture. This is actually one of the first pictures it took. And to me, this is phenomenal photograph. This is a picture, originally they thought, let's aim the telescope into a really, nothing's there, right? Black part of the sky, nothing could possibly be there, right? And that's what they picked up. A little background about how the Webb telescope is constructed. They have the mirrors down here, then they have arms that stick out from it, and then there's a camera up here aiming back at the mirrors. All these arms holding it create what they call diffraction spikes, which are those spikes on the picture going from that bright star in the middle. And the only stars in that picture are the ones that have spikes on them. There's, I think I see about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I think. There's only 10 stars in that picture. Everything else in that picture is a galaxy. Every single thing is a galaxy other than those 10 stars, which just boggles my mind. Those galaxies are like our Milky Way galaxy, possibly even bigger. They have millions or billions of stars in them. It's just, and they've now found that most stars probably have planets around them. And so it's astronomical number of planets and stars. So, and I don't think you're going to find too many books that start naming all those stars out there. You don't have enough pages to do it.
In fact, it's like 307, there are about 306 sextillion
Mhm.
stars, they figure. And that means for every.
Now let's talk about my favorite thing. This is the one that whenever I get on this subject. Okay, okay, I've already done that slide. I think I went backwards on these slides. You only go on the next one here. Okay, the Ryan Nebula, I mentioned earlier, that is a nursery. And they are, there's stars being created right now. And the leftover material from those stars will end up being planets and all the other stuff. So the space is not a static thing. And I'm going to show you something in a second here. Okay. We like to think of things you look for when we're trying to find whether life could be existing somewhere else. The the search for life beyond Earth. What is needed? Well, one thing we do have on the Earth is water. And how much water do we have? That picture, there are 3 little blue dots on there. One larger dot, one about 4 o'clock from there is a smaller dot. And then right about 6 o'clock below that smallest dot, a little teeny dot. The first star is the amount of water on the entire Earth, all the oceans, rivers, in the sky, moisture, and everything else. The water in that middle dot, that's how much water there is across, all of Earth. That's somewhat usable. The tiny dot at the very bottom is how much drinkable, potable water there is on the Earth.
Wow.
Kind of blows your mind, doesn't it? And so when we're going to other places to look for water,
Good God.
we're going to look for things that might be on other planets in our own solar system. You might look for evidence of past life. For instance, on Mars, we know there probably isn't any life on it now, but at one time we now know through our studies that there was water, probably oceans, rivers, and there could be life, could have been life there at one point. One of the things that I think is fascinating is that when the rovers were driving around Mars, one of them, if you remember, had a broken wheel and it would drag to the, I won't say the Earth, drove to the soil underneath it. And they took the camera back, showed it on that tire track on the soil. And what did they see? Anybody guess?
Ice. Right?
No, actually moisture, water percolating,
Right.
evaporating into the atmosphere, wherever they have on Mars. So they think, well, there is moisture there. They're finding evidence of water, perhaps at the pole. There is water at the poles and ice. There could be water down in the, what do you call them, the lava tubes and places like that. In fact, now they know there is water on the moon, down deeper in the moon. And they now know Enceladus, which is one of the moons, that's the moon of Saturn. Also, there's a moon of Jupiter that also has water on it. Enceladus, they believe so much water on there, there's actually more water on the Earth. There's a thick ice crust around it, and there's actually water that's percolating out of that, you might say, almost like little jets from a volcano. Those aren't volcanic jets, those are moisture or water being blown out of the lower parts of Enceladus. So there's probably a good chance there's an ocean below that several miles of ice. So one of our future space program plans is to go there and use some way to melt through the ice, get down and start exploring down in that ocean that's down there. So that's one possibility. Okay. Have any of you ever seen a dinosaur walking around?
Yes.
The movie.
On
Tell
movies?
us the
No,
birds.
and a bird.
Yeah.
And a bird. But I mean, the dinosaurs like we know, the brontosaurus and T-Rex and everything, we've never seen those, but how we know they existed because we've dug down and found their skeletons, right?
Right.
And so let's say you go to Mars, we know at one time they had water there. They could have had life. They could have had life. We haven't found it thus far, but if we go there and dig down and find something down there, doesn't have to be walking around today, but it could be down there. It could be evidence of not a creature, it could be evidence of a plant life down there. That's still life, right? Let's go on to something else. Okay, this is my absolute favorite thing to talk about, especially with school children. I first found out about this because my youngest son, who now is 26 years old, U of M graduate, but when he was in, I think, 4th grade, 5th grade, he was really into astronomy. In fact, he belonged to the Astronomy Club then and now. And so he used to go and talk to his teachers about it. And it turned out his teacher was really into astronomy. And so my son said, I'm going to go out and make a report. Can I make a report to the school? So he got a book from National Geographic. It was a magazine called National Geographic for Kids. And in that magazine, they had an article about a tardigrade, or which is also known as a water bear. And that's an extremophile. And the little creature is very small, about the size of a pinhead. That's about it. They're all over the earth. This creature has been here way before the dinosaurs even dreamed about being here. It's been here forever. They're extremely durable. They can be taken down to almost 0 degrees. They can, negative 0 degrees. They can be taken about 300 to 400 degrees above. And guess what? They do just fine. In fact, if you freeze them, they go into hibernation. Tardigrade is called a ton, TUN state. When they're in a ton state, they can last 5 years, 10 years in hibernation, warm up a little bit, put water back on, and guess what? They come back to life. You say, where are these creatures? Well, on the earth, they're all over. If you go out if you have a ditch going by your house, some water's been sitting there for a while, they're in there. You can actually take them out of the water. And I've got a microscope I can put on my microscope slide. That's something I have done this, and you can see the little creatures swimming around. That's the tardigrade. And there are creatures like that all over the earth that have ability to live in extreme conditions, whether it's very freezing, very hot, harsh conditions where it's very caustic to life. You would think life couldn't live there. Mono Lake, it's a very harsh environment, yet there are creatures that live there. They can do just fine. They live there. There are, in England, there are regular earthworms like you might have in your garden. Okay, well, they have earthworms there in a hazardous waste site in England. And it used to be, I think it was a copper mine, I believe, but I have all kinds of hazardous waste material in there, including a lot of arsenic. Well, it turns out these earthworms can go in, they actually are able to dig through this, they can remove the soil with the arsenic, and the arsenic is expelled out. It doesn't kill the worms at all, they're fine. The soil actually is, you might say, cleaned because of those animals, those worms working there. So that's another extremophile. There are worms, giant worms at the bottom of the sea in the Marianas Trench that are living in places that have never even, couldn't even possibly have seen any solar activity. They're so deep, it's just pure black down there. They live near volcanic vents. They're exposed to hydrogen sulfide. Venting out of there, it doesn't hurt them. They do just fine down there. If that creature could be brought back to the surface again, it would be smashed like a bug because it's used to living in huge pressures deep like that. If you went down there, you would not survive. Remember what happened to the submarine that went down trying to look at the Titanic? Unfortunately, it didn't like the pressure of the deep sea like that. So there are chances that even though we know it might be hard to find these creatures out there, there's a good chance we may find something out there, because whether it's a blade of grass, a microbe, bacteria, that is still life. And the latest things they're finding now on the asteroids we're going to, the comets, they're finding the markers of life on those. They pretty much said everything that could create life is out in space already.
Sorry.
That's all right. You're forgiven. He's my old buddy. We had to put up with each other. I made a trip twice for solar. So at the end of the trip, luckily we didn't kill each other. My son was with us the second one to keep us from killing each other. Okay. And I want to repeat something I said at the very beginning of my talk. You can be sure that most of the things people believe about the universe today is wrong. If anyone tells you something is a fact, don't believe it, because the new Webb Space Telescope and other modern science is telling us now that much of what we know for sure, well, maybe we don't know for sure. Okay, I think that's my talk. Anybody have any questions? Any further things to add to my talk?
Couple things. To give you an idea, when you're talking about the amount of numbers that are involved in stars, there are known to be about 300 sextillion stars. And if you wanted to give another number, the number of grains of sand on the Earth is probably 47 quadrillion. So for every grain of sand on the Earth, there are 24,000 stars.
Yeah.
To give you an idea of how big and how massive this entire place is. It's stunning. that one thing.
Yeah, and I agree with Ken, except I think that may be a little number now because the Webb telescope found out, well, we thought this was the limit, right?
Right.
Well, now it's a lot farther than that.
That's
So
what we're talking.
guess what? When you go this way, you're not just going this way, you're going this way. So this huge additional area you're picking up. So,
Well, you're talking about 93 billion light years
yeah,
across the thing, even though it's only supposed to be 13 billion years.
Yep.
old.
Yep.
Go figure.
The farther the things are out there, that's, they're moving faster at a rate of speed even faster. The farther
Mhm.
you go. but that's
Faster it's
something-
going, right?
We'll keep on
The
going
universe
faster.
is actually expanding.
Yep.
So,
Apparently, there's dehydrated tardigrades on the moon right now.
right. Yep.
There was a mission that Israel launched, a
Yep.
lander in 2019.
Yep.
It had dehydrated tardigrades by the thousands on there, so they're on the moon right now.
Yeah,
There you go.
It crashed.
yeah, crash on the moon,
Yeah.
yeah.
One
But
of
the
the
tardigrades are still there.
And what are the chances of us finding human beings out from the universe? Virtually no chance at all, because we are evolved as humans for about 200,000, maybe 300,000 years. The dinosaurs died off 65 million, and we are the result of
Lots of evolution.
evolution. And what you're doing is the microbes, if they started in the same place, carbon-based, you know, the very, very beginning, and they evolved the way we have evolved, or the kind of animals on the earth, or whatever, we're closer related to a blade of grass than we would be to any other life form. That's pretty far fetched.
I find myself,
Absolutely.
Yeah.
people know the universe is big, but they don't know the scale of
They
things.
can't.
They struggle with the scale. I had a scientist who said how far away is that in the travel like this? And no.
No, you can't get it, they don't get it.
But then, I believe most astronomers, if not all by now, believe that on top of all those stars, every one of
Bob.
them has at least two
Bob.
or three, thank you,
2 or 3 planets.
planets, right? So.
Yeah.
Now you're talking about a whole lot of planets too.
I want to show one picture on here. How to get out of this, go back to, I,
Bobby, that was great.
okay. Back on my, well, we can do something. I won't show it now, then I'm back on the videos.
Bob, I did want to add, there was an experiment a few years ago where they actually put the number of microbes on the surface outside exposed to space of the International Space Station. And they proved that spore-forming bacteria, fungi, and archaea were all able to survive for 6 months
Mhm.
out there on the surface of the ISS.
Yep.
In something close to a vacuum.
They have one thing.
That's
One thing I used to, when I was, I'm also with the, it's in California, the Academy of Sciences. When I lived in California, I was a representative there for astronomy. And one of the things we developed when I was there was a poster, and fortunately I got it on my computer. But if you think of it this way, if you put your hands like this, okay? This fingertip is when the earth was created. This fingertip is today, okay? Now, along that, various things happen, like mass extinctions, and there were 5 known mass extinctions. The last one was probably the dinosaurs, okay? If you use that same time scale all the way out here, if you take a nail file, take one swipe against your fingertip, you've just removed the entire time that man has been on the
There
earth.
you are. That's the point. Right.
Now, let's say you're looking for an alien, okay, or you say, have aliens looked for us? Okay, and let's say you've got 2 civilizations. If those 2 civilizations, if you walk 1 inch this way and he walks 1 inch that way, guess what? They don't line up. So now one is far advanced beyond this one, another one is far behind, right? So the question is, if there's an alien civilization that could come to Earth, we'd be either number 1, like pond scum compared to them, or number 2, remember the was it the insertion, or was it? Remember the one about man, basically it was a cookbook. Serving man, you know, so you gotta be careful, you know. You wanna have aliens here. Okay, so you can keep this, if you want to make copies of this, give to other people, if you have kids in the school, whatever, give it to their teachers, whatever, because kids love this type of stuff. It just boggles their mind. Okay.
All right, fabulous. Thank you so much, Bob.
Yes.
Okay, thank you, everybody. Thank you for bearing with us through the technical difficulties. We promise we'll have video feed at the next one. So right now, those of us at Macomb are all invited to go to the Coney Island. They're actually the back of the Coney Island. There's a bar called Jimmy's that we go to. It's the National Coney Island on Van Dyke Road, just north of 12 Mile. So we go in through the back entrance. Yes, Ken?
You want to mention that movie that's going to be showing on Saturday, it's all about the Hubble?
Yes, so we put out an email blast about the Hubble movie coming up. Let me read it so I don't have, since I don't know it off the top of my head. So it's called IMAX Hubble 3D, prosaically enough. It's going to be at the AMC Forum 30. That's this upcoming Saturday at 12 p.m. It's got a 45-minute runtime. And there will be a visit to Dunkin' Donuts / Baskin Robbins afterwards. So if you go, you will be able to hang out with your fellow astronomers. All right, so see some of you at the Coney Island and the rest of you. Jonathan and I will not be at the next Cranbrook meeting. We will be in Puerto Rico with our nieces.
We might be joining remote.
We might be joining remotely depending on how the nieces are that Monday night. So we'll be thinking of y'all and hopefully under starry skies. Have a good one, everybody.
Yes, so if you decide, Van Dyke, Van Dyke, just stand like this.
I don't know.